Today we are going to discuss about the logistic regression. The logistic regression is basically used whenever you are having the categorical variable. Whenever you are having the categorical variable, this is used. Means, for example, if you have uh, two or three outcomes to which you cannot assign any uh, number that is the continuous. So for example, the disease is present or the disease is not present. Like you studied 100 patients and out of 100 patients 52 are showing the good response. So that is the categorical variable. This is not continuous variable. For example, the height is a continuous variable. It could be 5 feet 1 inch or something like that. But the categorical variable means either the thing is present or it is absent. So this is the logistic regression. So whenever you are having the categorical variable, it is used, and whenever you are having the outlier in your experiment, then also it is used. For example, then why we are not using the linear variables is this, because let's say if you have the tumor size and if you have the probability, let's say this is the probability of malignancy and this is your tumor size. Let's say this is 0 centimeter, that is there is no malignancy. If it is 0.5, sorry, not 0.5, let's say 5 centimeter, there is a malignancy. We give this the number 1 and 0. These are the categorical values. So when you will make the line, you will get something like that. But what if you are having a tumor size of let's say 20 centimeter? Then also the malignancy is there because it's more than 5. Then this line will shift from this to here and your results may not be accurate. Like if you calculate the 50% probability, you will get numbers like this. But if there is an outlier, you will get something like that. In this case, at this tumor size, you will say there is a 50% of the chances that the disease is present or not. However, this is not the case. So, in these cases, whenever there is a categorical variable, whenever there is an outlier, the logistic regression analysis is used. In the logistic regression analysis, the outcome, which is your independent variable, and the exposure, which is your dependent variable. We try to find out the correlation or the probability between these independent and the dependent variable. Then we use the logistic regression. So whenever you try to find out the correlation or what is the probability that actually the dependent variable is dependent on this exposure, then the logistic regression analysis is used. Let's consider this with an example. In most of the cases, what happened, the gestational age is 36. So it is 36 weeks, so 9 months in humans. I'm talking about. This is the gestational age, which is the independent variable, because this is not going to be changed. And this is the breastfeeding at the time of when the child is leaving the hospital or discharging from the hospital. Whether the child is on the breastfeeding or not. When the status of the child with respect to breastfeeding at the time of discharge from the hospital. So as you can see here, in the 28 weeks time, there are 6 childs we observed, and out of 6 children, 2 were on the normal breastfeeding because breastfeeding is normal. However, 4 were not on the breastfeeding. Okay, and we want to correlate. Okay, this gestational age has anything to do with this breastfeeding or not? That's why we are using the categorical variable, because these are the categorical variable, number of kids, number of the child. So, what is the probability of buying? As you can see here, out of 2 are on the breastfeeding out of 6. So, this is the probability of buying. So whenever you are calculating the odds is defined as the probability that the event will occur divided by the probability that the event will not occur. For example, and in case of the 28 weeks, it is 0.33. This is means the event will occur, means the child is on the breast week. 1 minus 0.33 means the event will not occur, means the child is not on the breast week. Then it will be something like that, and you will be getting the number 0.5. What is this? The event will occur, that is like this, and this is like this. The event will not occur. So, like this, you can calculate it. And let me just show you how we can calculate it. So here you can see the same thing. We have taken this is the number, as you can see, 0.69, and this is the same thing, 0.69, 0.055. And if we are taking this is the same thing. So now what we can do, we can just make a scatter plot out of it. We will go to the insert, make a scatter plot. Okay. And then we will just click on this and make the trend line, which is your linear trend line. Just click on this trend line, this line, go to this here, and you will be getting the display equation of chart. So you will get this equation on the chart. So for now I'm deleting it. You can see it is here. So this is 0.629 is the slope and 18.29 is your intercept. You can also calculate it. How you can calculate it? Just type slope. Go here. Do this here. And you can calculate the slope. Similarly, you can calculate the intercept. This one, this one. So both way you can do. Either you can do it by using this graph, by making the scatter plot, or you can do it by using the formula that is inbuilt in the Excel. Whatever the case you like, you can do. Now we want to calculate the predicted LN odds. How we can do that? Because X is different in these cases. What we will do, we will just do, what is the slope? This is the slope, multiply by X, which is X, then plus, and this is your intercept. So this is your case. But as you can see, slope is same in every case. So what we will do, we just add the dollar sign here, the dollar sign here, and the intercept is also same. So we'll just do the intercept here. And when you will do this thing here, you will get exactly the same thing. Now you will calculate the exponential of, because the probability is calculated by this formula, exponential of the ln mod. So now you will calculate the ln of this. How you can do that? Just go ln and do this now. So you can calculate. Sorry, explanation, sorry. So just go do it the explanation, this thing, and go here, and you will get the similar stuff. So you can just calculate it and you will get this number. Now see, the probability is like probability exponential of odds, which is this number, 1 plus y, which is this number. So your predicted probability, as you can see here, this divided by this, which is the exponential by this is what number? If you calculate, this is a 1 plus y. So like this you can calculate it. Now we are going to take these numbers and these numbers. So this is going to be our x-axis when we are making the sigmoidal plot, and this is the predicted probability that is going to be on the y-axis, that is the predicted. So x-axis is the gestational age, this is the probability. Now you can either do it by using this Excel itself. You can just go here and make a scatter plot. Okay, and you can use a trend line which is exponential, so you'll get something in there. But you can also use the software like this. If we are doing this, we are making a scatter plot and we are doing the analysis. This is the origin software, and then we can go with the sigmoidal fit and we can just do it. Data selection, this is a software based on the whatever the software you are using, you can make it. Here you can see the formula is in the log. When you will click or you will get these are the things which you are going to get. You can just delete it. Here you can see you are going to get exponential plot. So this is the probability of your event when the child is on the breastfeed, and these are the gestation age, which is the weeks. As you can see here, the child gestational age is 33 weeks, then the probability of having the breast milk means the child is on the normal diet. Its probability is 90% of the probability is there that the child will be on the normal breastfeeding diet when the gestational age is 33 when compared with the 28 weeks. Now we will apply with the logistic regression analysis. We'll just go to the another. So here you can see this is the 33 weeks, this is the 28 weeks. You can see here in the 28 weeks, 2 child were on the normal breastfeeding diet, while 4 were on the not breastfeeding child. You can see here as well. In this, also you can see the 4 were not on the breastfeeding, 2 were on the breastfeeding. Similarly, for the 33 weeks, 14 were on the breastfeeding, so 1 is not on the breastfeeding. The similar thing we have done. Now what we will do, this is software. So for if you have SPSS, you can do that. I have this origin software. I'm using it. Just go to the logistic regression and click it here. What is your dependent variable? The AX means whether the child is on the breastfeeding or not. What is your categorical variable? This is your, and now you can give the reference event 0 and 28 weeks. 28 weeks is our reference event. So this will calculate odds factor for the 33 weeks. So if you will go here, you can see. So we have the reference event here 0 means the child is not on the breastfeed. So the odds ratio is coming 0.07, but when we are doing means odds ratio, if it is like less than 1, then it is showing that the child when the gestational age is 33 weeks, which you can see here, the child of not having the breastfeeding diet is very less. Okay? We can do it in the other way around as well. We can just do the logistic regression. And here we can change to 33 weeks and the reference event is 0. So here you will see the odds ratio increase means when the gestational age of a child is 28 weeks, the child of having no breastfeeding, this chances, the probability is quite high, which is 2. So here you can see when we are giving this the reference for 28 weeks, it is calculating for the 33 weeks gestational age. So it is showing, this table is showing when the gestational age of a child is 33 weeks, then the child is having pretty much less chances that it won't be on the breastfeeding. But if you are calculating this thing for the same thing for the 28 weeks child, there are double chances that the child will not be on the breastfeeding diet. So this software, by this you can calculate it. So this is just the odds ratio. So this is by the logistic regression analysis, we basically calculate the odds ratio, means what is the chances that the event will occur when the exposure is there. So if it is like 20, and we can also change it, like you can see here. If I change it to, let's say, the reference event, if I give 1, and the same thing, let's say I will do the 28 weeks. You will see odds ratio is high here. You can see when the reference event is 1. Similarly, when you are doing it with the odds ratio, so that's how you can calculate. So everything will reverse. Here the thing is this, it is very clear if you see on the sheet that if the gestational age of the child is 33 weeks, then it is definitely affecting the outcome, means the child breastfeeding is more. And the same thing we found it in our plot as well, based on the odds ratio. Okay. This I already told you how to do this thing, and this also I did. So now you can calculate the likelihood ratios. Means the likelihood ratios are used to express the change in odds. If the value of LR is greater than 1, then there are chances that there is a positive correlation between your outcome and the exposure. If let's say the LR is positive 10, then the tenfold chances of your event, of your dependent variable, your dependent variable is going to dependent on your independent variable, is going to increase in the odds of having a particular condition of a patient with a positive test result. Similarly, if it is greater than 1, there is a positive correlation between the dependent and the independent variable. Chances of having a positive correlation is pretty much high, and that is called a likelihood ratios. If the value is 1, means there is no, you can see here, if it is like 1, then the test is useless. If it is negative, then your dependent variable and the independent, the correlation is in the negative way. Means if your exposure is increasing, your outcome will decrease. So here you can see LR, if it is more than 1, means your outcome and exposure are directly correlated. Chances are pretty much high. When LR is 1, there is no correlation. The test is useless. And when LR is less than 1, then your outcome and your exposure is having that inverse relationship. So this is your likelihood ratio. There are something which you can see here as well. This is something like qualitatively you can just means roughly if you are having a value, you can just see and means sense it. What is the what are going to be the results? For example, if it is like LR of 5, there is a moderate increase. If LR of the 2, there is only a small amount of increase. And when the LR is 1, then the test is not capable of changing the post test probability either up or down. So what you need to remember is when LR is more than 1, the outcome is directly related with the exposure. When LR is 1, your test is useless. And when LR is less than 1, means if it is negative, then the outcome is having inverse relationship with your exposure. This is just a qualitative sense. You can just ignore it as well. This is a rough estimate. If you are having an LR of 2, then the chance probability of a disease is 15%. If it is 5, 30%. If it is 10, 45%. Like this. Negative means if it is LR means negative 0.5, then negative 15%. Negative 0.2 means negative 30. Negative 0.1 means negative 45. And this is a rough estimate. If you are doing these, if you are calculating the LR value on a regular basis, and if you are seeing, okay, my LR is coming 5, so you can say there is a direct 30% of the chances that my exposure and the outcome is going to have a direct relationship. Now we will go with the multinomial logistic regression. For example, let's say in the previous example, in the binary logistic regression, we have only two things, either 1 or 0. In this, what we are having 1, 0 and 2, and that is why it is called the here the categorical variable is not binary. It is like here you can say tertiary because these have three values. Like if we give the doses of 20, then the dead will be out. If we are, let's say if there are 21 patients, and out of 21 patients we are giving the 20 microgram dose of some drug, and then 13 of them they are dying, 1 is cured, and 7 are sick. Similarly, in case of the 21 microgram of doses, the total number of the patients are 97, and out of 97, 60 were dead, 6 were cured, and 31 were sick. So here you can say, let's say if this is the 21 and the 20 dose having, and this is the cured, how many cured? In 21, you can see 6. Then remaining is how much? How much you can see? 60 plus 31, which is 91. Similarly here, how many are cured in the 20 dose? It is 1. And how many is the remaining? This is 20. Similarly, if we want to calculate the probability of the cured patient, if you want to calculate the probability of the sick patient, then how many are sick? Here you can see sick are 36, sick are 31. And what are the remaining? As you can see, 60 plus 6. How many sick in case of the 20 microgram dose? It is 7. This one. Then how many are remaining? Is 40. So whenever you are calculating the odds ratio, you have to do the diagonal multiplication. What you will do? You will just calculate here this with this, and here you will calculate this with this. So you can just do you can do here. Similarly, here you can do this versus this, and here you can do this versus this. Then what is your OR of being cured is 120 by 91, which is 1.31. And what are the chances of sick? This is this divided by this is 0.93. So we are calculating with respect to the 21 microgram of dose. What we will get in the 21 microgram of dose, because it is the OR is more than 1, means if we are giving the 21 microgram of dose to the patient, then chances of their cure is going to be much more than that of sick. Okay, because it is 1.31. So for sick it is less than 1. So this is 0.93, because since it is 0.93, means this is less than 1. So we can say that 21 microgram dose is more effective than the 20 microgram dose. However, this is not significant. As you can see, it is not much lesser than 1. It is not much higher than 1.1. You can also calculate by doing the normal statistics, like sick is 7 out of 21. Here you can see 31 are sick out of 97. The probability of being sick In case of the 20 microgram dose, it's less because 0.31 is lesser than 0.33. However, this number could not be significant. Similarly, in case of the cure, you can see 0.061 means which is higher than 0.047. So 21 microgram dose is more effective if you are talking about in terms of the cure. How many patients are cured and how many patients are sick, then 21 microgram dose is less effective. Okay. So basically nobody want to be sick, so what we will say, 21 microgram dose is more effective. So that you can calculate by doing the multiple logistic regression. So let's say out of 20 microgram dose, how many are cured? Dead. Dead are 13 and cured are 2, 1 and the sick are 7. So here you can see 13 are dead. How many? These many are is this number 0? 0 is sick. Sick are 7. So 7 are going to be the same and and 2 is for cure. So these many are dead. 13, 1 is cure and the 7 are sick. Similarly, we calculate for the 21 because there are 3 numbers 0, 1 and 2. So we cannot apply for the binary logistic. We will go for the multinomial logistic. So what we will do here you can see the categorical variable is going to be your doses and then you can calculate it. So here you can see 1.3 and the 0.95, exactly the same number we got is 1.3 and the 0.95, approximately same. What we can see here, 21 microgram of dose, the chances of cure is more, which is because it is let's say if it is 1.3, cure is more, and 0 is what? 0 is dead. 0 is sick. The chances of sick is less. 2 is for cure. So at 21 microgram of dose with respect to, because your reference event is 20, so when you are comparing 21 with the 20, so you will see 2 number is showing high OR, which is 1.3, and what is 2 means cure. So you can see the chances of curing of the patient when you are giving a 21 microgram dose is high, and chances of that they are going to be sick, because if you see the sick value, the OR value in the sick portion, it is 0.95. The chances of having sick when you are giving patients a 21 microgram dose is quite less. And the same thing we have calculated in the Excel as well. So as you can see here, one more time I would like to tell you that these are the doses which you are giving, and you studied out of 21 patients, 13 are dead, 1 is cured, 7 is sick, and then you just calculate the cure. So what you will do, how many are cured? 6 are cured, as you can see here. And how many are cured in terms of the 20 microgram dose is 1. Similarly, if you are going to calculate the sick, then in case of the 21 microgram dose, 31 are sick, and in case of the 20 microgram dose, 7 are sick, and whatever the remaining you can write it here. So and then you will just do the diagonal. Here you do the diagonal, here you do the diagonal, here you do the diagonal, and just then this is your odds ratio. Okay. this is your odds ratio. We'll write here, this is your odds ratio, and the same thing you got it. You will see this table, you can see in case of the 21 microgram of dose, 2 is the number that we gave to that cured patient. Chances of curing of the patient is high because the odds ratio is more than 1, which is 1.3. However, the value is not significant. So this is regarding the multinomial logistic regression. So this is all about the logistic regression. Thank you so much. In our next lecture, we are going to study the patch track. Thank you.